Next up, Raghi Iyengar and Patrick Spink will talk about DFMA, Design for Manufacture and Assembly, and will point out how this engineering and construction methodology simplifies the production and assembly of building components, enabling construction projects to be completed faster, more sustainable, and with a higher level of quality.
Hello, everybody. Thanks for joining us again and learning what's new at ALLPLAN. Today, we are going to be speaking specifically about DFMA and really providing a general overview of what DFMA is all about. Joining me today is the infamous Raghi Iyengar. Raghi, tell us a little bit about yourself and why I guess went ahead and introduced you as being the infamous Raghi Iyengar.
Thanks, Patrick. Hi, everyone. I'm Raghi Iyengar. I've been in the construction technology for over 35 years. So known a lot of people in the industry. So maybe that's why Patrick calls me the infamous. But I've been around this space for a while. And I was a founder of Manufacton to bring the best of manufacturing to construction. And Manufacton, as you all know, was acquired by ALLPLAN in March of this year. So I'm excited to talk about DFMA for the next few minutes.
Fantastic. Thanks, Raghi. I just learned I have a new role, a new title at ALLPLAN, and I am now part of the Fabrication Center of Excellence, which really shows the commitment that ALLPLAN and Nemetschek have to DFMA and all things fabrication. So that's a little bit about me. I've been in the AEC space for most of my career, spent a lot of my time on the design side of the world, and most recently, prior to joining Manufacton, I was with an organization that really focused on operations and what happened after handoff or commissioning. So that's a little bit about me. I'm gonna just let us jump right into the topic at large, which is what is DFMA, Raghi? When we talk about DFMA, it means a lot, but give us the real quick high-level overview of what it is.
Sure. So DFMA, as you all know, is Design for Manufacturing and Assembly. So if you think about that, it's been in the manufacturing space, it's been there for a very long time. When you talk about DFMA in the context of AEC, it is the approach of designing components so that they can be fabricated easily in a controlled factory setting and then delivered to the job site and then easily and quickly assembled on site. So it's kind of that whole life cycle process.
So it kind of incorporates DFMA. You hear precast, prefab, offsite fabrication, offsite construction, modular construction. It really kind of encompasses all of that. There's not one specific thing that kind of points to, hey, this is what we are. So let's talk about some of the basic principles of DFMA, Raghi. What is it a little deeper? Let's peel the onion a little.
Sure. So I think the first part of it is when you're talking about DFMA in terms of it's all about you start with the productization and the standardization of components. And what we mean by that is you're trying to have fewer and fewer product or parts of a product and that you want to then have kind of use and try to simplify the building into as many pieces, smaller pieces and similar pieces as you have. So because that will then help reduce the complexity, it minimizes errors, and at the same time it reduces your assembly process and kind of so it's the whole idea of simplification by standardizing on components and using a productization approach to doing it. And then you're talking about the optimizing for prefabrication. So as you're designing it, you're thinking about how is this going to get produced in the factory, how is it going to get delivered to the job site, and how is it going to get quickly assembled at the job site. So it's that whole productization and then the optimization for prefabrication. But as you can see, as we're talking through it, you're recognizing the fact that, hey, this really requires early collaboration with all of the stakeholders involved. So the designers working with the factory folks as well as working with the field folks in order to all say, how are we going to do this so that it can support it downstream, etc., through the whole workflow. So all of this kind of comes together as the core principles of DFMA.
That makes a lot of sense, Raghi. I really appreciate it. So when we talk about the benefits of DFMA, I guess a little bit more tactically, it's reducing the number of parts. So when we talk about reducing the number of parts, it's like I have one part that really is replicated on multiple projects, but there's 15 different vendors that I'm buying it from, 15 different SKUs, 15 different item numbers. It really is like, hey, let's reduce the number of parts that we're actually moving through here so everybody knows how to put these things together. It's very similar from that standpoint. So it makes it easier to assemble. Certainly gives us a higher product quality because we're knowing how to put every one of these things together continually. When we talk about DFMA from one specific standpoint, what is it when we talk about shorter construction time? You know, some of the people I'm talking to say, yeah, you know, it's not really I'm not doing it anything any faster. What are we talking about when we're saying shortening the construction time?
So I think, so Patrick, one of the things that we look at is if you think about on-site construction in general, you're talking about a sequential process. You know, you're building the first floor, and then you're building the second, and then you're building the third, etc. And if you have delays happening in the first floor construction, then the second floor construction cannot begin until first floor is done. And then if there are delays in doing the second floor construction, that's going to then compound it so that the third floor is going to get even further delayed. So you have this constant kind of cumulative delays that kind of starts building up as like a compounding effect. But if you start thinking about it in the context of, you know, DFMA and producing things in parallel in the factory, so the different factories for different components and assemblies and modules, they can produce those in the factories in parallel. They don't have to wait for the third floor to be ready for them to produce what's going to go into the third floor. They can do that in parallel, so and gets delivered. So even if there is some slight delays in the first floor, you have the opportunity to catch it up in the second floor, and then probably even make it more efficient as you get to the third floor, since all of those pieces are there. So the net from all of that is, instead of this cumulative delays with the compounding effect, you can actually shrink the construction time for the overall project.
Which brings us right down to that final point, which is lowering the project cost, right? While it might not necessarily cost less to fabricate in the shop, it gets done quicker, right? Which means the owner is happier and willing to pay a higher price because the stuff's getting done on a timely fashion on the overall schedule. So while delays are happening here, you can kind of continue moving along, which again just reduces that total cost of the project. People can open the doors for retail space faster. They can open the hospital beds faster. They can turn on data centers faster. It's all about what the end result is, and it's being able to get that stuff done in a more timely fashion. That summarizes it pretty simply, right?
Mm-hmm. Yes. Mm-hmm.
So with all phenomenal technology changes, there always seems to be some type of challenges with the adoption of DFMA or design for manufacturing assembly. Let's talk through a few of those real quick.
So the thing is, if you look at, as we said, the DFMA has been in manufacturing for a while. So if you think about cars, for example, they get assembled from identical mass-produced components. But then when you're talking about a building, you're talking about components that need to meet individual requirements. So there is a different mindset for where AEC requires mass customization and not mass production. And that has its own challenges in terms of production, in terms of logistics for delivery, and kind of managing all the individual lead times and so forth. So the challenges are there, but overcoming it is where, you know, you can have a significant benefits, as we have talked about earlier.
And one of the areas that we talk about, you know, manufacturing specifically in terms of being able to manage quality, why do you really kind of consider that as a challenge of the adoption of quality control? I mean, that would seem like it would be better and be able to manage it better. What are the roadblocks that kind of pop up there, and why is that a bullet point?
So the thing is, if you think about traditional construction and you see a quality issue at the job site, you can just fix it there and you're done. But if you're following the DFMA process, granted it's a lot more efficient, better, et cetera, but you have to ensure that you have good quality control along the way, from the sourcing the materials to producing in the factory to delivering to the job site and finally assembling it at the site. And because anywhere along the way, if you have quality issues, that is going to get propagated across multiple of those things when it get to the job site, and now you may have 25 issues rather than one issue. So making sure that every step of the way, every work step, everything, you have really good quality control is key to ensure that at the end of it, there are no surprises when everything is put together at the job site.
Yeah, one of our customers actually alluded to the fact that prior to deploying our product, they had wall frames that were being delivered for a multiple tenant high-rise apartment complex, and the door for this specific interior wall was in wrong location, and they continued to build those wall panels and kept shipping them to the job site. The superintendent was saying, "Hey, this door's in the wrong location," but it was never getting back to the fab shop. Right, that communication was broken down. He said it got to the point where it was just easier to fix it in the field. But the challenge is the owner comes and sees that they're moving this wall frame, and they see him moving the wall frame 5 or 6 different times, right? Not the wall frame, excuse me, the door frame 5 or 6 times. And they start kind of questioning what else is going on that I'm not aware of. So that's what you mean by quality control, and actually recognizing, hey, we need to have a better understanding of what's happening and what's being delivered and what's being fabbed.
Yeah.
So then collaboration among all stakeholders is paramount. Talk a little bit about that.
Exactly, which leads us to, we've talked about it earlier, and we all know that in AEC, the companies have to collaborate to work on projects, and so they've been doing collaboration for a while. But in this context, that hey, you're collaborating to ensure that things are moving efficiently and smoothly from design to manufacturing to the delivery and then final assembly, and then making sure that it's a different type of collaboration that is needed with a different set of digital information that everybody is working with and working towards and so forth. So it's just highlighting the fact that it is a change, and it's just different types of collaboration, but it do need to recognize that in addition to the other challenges, that some of this has to be addressed as well.
Collaboration is more important now than ever before, and understanding and coordinating a BIM model is just as important as ever been, right? It's no more is it just you're getting some two-dimensional drawings as a byproduct of the modeling process. Now we're continuing it all the way through, right? It's the eye in BIM and the modeling of BIM, right? It's the BIM as a whole, not just one specific component.
Yep.
So how is manufacturing and ALLPLAN, how are they supporting, or how are we supporting DFMA?
So ALLPLAN has a very strong design to build philosophy. So ALLPLAN has been creating tools and information from the earlier, the data-driven decision making and better results. So it's kind of driving it from design, and also as you're looking at all of that information available, you're working towards automating the standardized design tasks, but you're also talking about covering the digital manufacturing process downstream, as well as how do you optimize your factory operations. So you're thinking about designing with the end in mind, both from how it's going to go into building, but also how is it going to be produced in the factory in order to kind of make things more efficient.
That's fantastic. And talk a little bit about Open BIM and what that means for the industry and ALLPLAN and EMACHET.
So with the whole idea there is, how are we going to implement this DFMA and support our customers through this process, and with the whole design to build philosophy, and as you're talking about, you're using BIM to manage your project to drive procurement, fabrication, QA, all of those kinds of things. The idea there is to deliver all of that in the context of an open BIM platform, so that so no matter what your engineering design tools you're using, whatever engineering analysis tools you're using, you'll be able to kind of collaborate with all of those things together in order to be able to make it really seamless for all of the stakeholders involved. And then that also together with the open BIM with what we are trying to drive towards manufacturing, it kind of comes together there.
That makes total sense. And when we talk about Manufacton specifically, we really are delivering multi-materials for multiple industries, designed for manufacturing. Currently, with wall panelizers, electrical, mechanical, modulars are really all of our customers at this particular point. ALLPLAN and Nemetschek bought us because they really see us as a competitive advantage for precast space as well as the steel space. Is there anything you want to add on top of that, Raghi?
So that's where we're super excited about how we have kind of come together. So talking about expanding into steel and precast, but also connecting up with the open BIM platform, which I think is a very powerful solution for and capability for the industry to have a really robust open BIM platform that can deliver multi-material DFMA. So there are no constraints around, hey, I need to do a single material stuff, I need to do multi-material, I'm going to use a different design platform to do this, another platform to do that. It does not matter. You should be able to work with everything involved with the open BIM and with multi-material DFMA. So that's where we are driving the solution and to support the industry as it evolves into this space.
That's perfect, Raghi. Well, that gives us a real good, quick, high-level overview of DFMA. I introduced you as the infamous Raghi Iyengar, but now it's the professor, because you get a really good high-level overview of what the product is or what the terminology is, and we look forward in all the things that we have to do at ALLPLAN in 2026 and moving beyond. So thank you, everybody, for your time, and we look forward to hearing from you soon.
Thank you, everyone.